Hello students, welcome back to Future Foundation. Students, in today's class, we will start the second part of vector and 3D, three-dimensional geometry. In this, we will talk about Cartesian coordinate system, distance formula, section formula, direction angles and direction cosines, and some questions based on them. So let's start the class. So student, second part is three-dimensional geometry. So in this first topic we will cover Cartesian coordinate system. Likewise in 2D um, there is a Cartesian coordinate system in which there were two mutual perpendicular lines, right? In this case also there are mutual perpendicular lines, but because of space, or we are talking in space, so we will take three mutually perpendicular lines, right? Say this is x axis, this is y axis, and this is z axis. Suppose a point in space, say point P is 1 2 3, having coordinates 1 2 3. So if this P is 1 2 3, means we are making a distance 1 unit on x-axis and 2 unit on y-axis, 2 unit along y-axis, and then 3 unit along z-axis, right? So if I complete a cube or parallelepiped, then it will become like this. Okay, so this is point P123, right? Means if this is origin, then OP is having projection on x-axis 1 unit, right? Or if this foot of perpendicular from P on x-axis is represented by m, then coordinates of m will be 1 0 0, or OM is 1 unit, MN is 2 unit, and PN is 3 unit, right? Also, if along y-axis, or you can say projection of point P on y-axis is represented by OQ, then OQ will be also 2, right? Similarly, along z-axis or on z-axis, projection of OP is represented by OR, then OR is also 3 units. Now, in this we will write Cartesian coordinate system. We will write, in this system there are mutually perpendicular lines called x-axis, y-axis, and z-axis, as shown in figure. If a plane is moving parallel to x-axis, which of the following will change? Options are x, y, B, y comma z, c, x comma z, and d. None of these. So if any plane is moving parallel to x-axis, right, then which of the following will change? See, students, if you are having a plane which is moving parallel to x-axis, it means what? If a plane is parallel to x-axis, then normal to the plane is perpendicular to x-axis, right? Now, if you are moving that plane, right, or you are moving a plane containing perpendicular uh, to the axis, right, perpendicular to the axis, so that perpendicular is moving. So if that perpendicular is moving along x-axis, so what will change? If you are seeing a perpendicular which is Pn in figure, say if this perpendicular will move along x-axis, or if I place this Pn on x-axis and it will move, so what will change? The only thing which will be changed is x coordinate, right? Nothing will be changed except this. So out of these four options, which one is correct? Obviously option D is correct. None of these, because only x coordinate will change, right? Got it? Yes. Now next heading is distance formula. See students, you will notice that 3D is same as of 2D, except in this one coordinate will be added. Okay, one coordinate is added. Okay, so if you are having 2 points and you need to find the distance between them, so you will use distance formula for finding the distance. Again, in this case also, if you are recalling the distance formula for 2D, then you will have root over x1 minus x2 whole square plus y1 minus y2 whole square. So similarly, in this case also, D is root over x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square, right? So if one point is P and another point is origin, so distance will be, or distance from origin is root over x square plus y square plus z square, right? As simple as that. Now next, distance of any point ABC from x-axis, see, if you are finding the distance of point ABC from x-axis, means you are finding the perpendicular distance, right? So if this foot of perpendicular is M, so coordinates M will be A 0 0. So using distance formula, we will get root over B square plus C square. So distance of ABC from x-axis is nothing but distance of ABC from foot of perpendicular of ABC on x-axis, right? Again, it is distance of ABC from A00, and which is equal to root over b square plus c square. So if you are finding the distance of point from x-axis, then x coordinate will be absent in distance, right? So similarly, if you are finding the distance of ABC from y-axis, right, or 0 is 0, so it will be root over from y-axis. You can write from y-axis, which is root over. So if you are finding distance from y-axis, then y coordinate will be absent. So this will be root over a square plus c square. And distance of ABC from z-axis, so it will be root over a square plus b square, right? Okay, now question is, if square of the distances of a point from coordinate axis having sum as 36 units, then find the distance origin. So point ABC, right? And in question it is given that PL square plus PM square plus PN square is equal to 36, right? It is given square of the distance of a point from the coordinate axis having sum as 36. So square of the distances, right? Then sum of the square of the distances is 36, right? And this PM is perpendicular to this y-axis, right? In 3D figure will be like this only, because we are making figure of 3D in 2D. So this PM will be seen like this only. So according to the question, PL square is nothing but B square plus C square, plus PM is A square plus C square, plus PN square is A square plus B square, is equal to 36. So this will be 2 times A square plus B square plus C square, which is 36. So 218 is 36. So this is A square plus B square plus C square is 18, or root over A square plus B square plus C square is root over 18, right? So this root over A square plus B square plus C square is nothing but distance from origin. Distance of P from origin, and which is root over 18, which is 3 root 2 units, which is required answer. Okay. Next question is, in 3D, x dot y is equal to 0 represents option A, two perpendicular lines, option B, two parallel lines, option C, two perpendicular planes, and option D, none of these. So if I see the equation, or I write the equation, then this is x into y is equal to 0, right? So either x equal to 0 or y is equal to 0. So x is equal to 0 represents yz plane, because in yz plane x coordinate will be 0 only, and y is equal to 0 represents xz plane. So because in xz plane y coordinate is 0, so xz plane or yz plane. So xz plane is perpendicular to yz plane. So in 3D, x into y represents what? X into y is equal to 0 represent what? Perpendicular planes. So you can write these are two perpendicular planes. Okay. Now next question. In 3D, x square plus y square is equal to 0 represents option A, two perpendicular lines, option B, two parallel lines, option C, two perpendicular plane, and option D, none of these. Okay, bache. So if you are given x square plus y square is equal to 0, it implies x is equal to 0 and y is equal to 0. Then only equation x square plus y square is equal to 0 will satisfy. Okay, will be satisfied. Okay, so x is equal to 0 represents yz plane, and y is equal to 0 represents xz plane, and these cases are simultaneously. Okay, is equal to 0 and y is equal to 0 are simultaneously, means they should be 0 at the same time, right? So if I draw x is equal to 0, means yz plane. Yz plane is this. Y is equal to 0 means xz plane. Xz plane is this. And these two planes are simultaneously occurring. Means if we are having both planes at the same time, then this is only possible when this line will occur, or this z-axis. So this will be z-axis. So x square plus y square is equal to 0 represents what? Z-axis. So none of the options is correct, means option D is correct. Next heading is section formula. Section formula is a formula which gives the point or coordinates of the point which is dividing the given segment in given ratio, right? Say this line or this segment A is AB having x1, y1, z1, x2, y2, z2 as its endpoints, and a point C is lying in between AB such that this C divides CB in the segment. The ratio is m is to n internally. Then coordinates of C will be mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n, comma mz2 plus nz1 upon m plus n, right? This is for internal division, and in external division there will be minus. Okay, now let's write some remarks. Remark 1. If line AB is divided by xy plane, then z will be 0, or mz2 plus nz1 upon m plus n will be 0, means m upon n will become minus z1 upon z2, right? This case we have seen in 2D also. Say if in that case, if line AB is divided by uh, z-axis, sorry, y-axis, right? Then y coordinate will be 0. Okay. Then m upon n in that case will be minus y1 upon y2. Okay. Sorry, if line AB is divided by y-axis, then x coordinate will be 0. Obviously. Then m upon n will be minus x1 upon x2. Right? Okay. Now, remark 2 is, if a line joining AB is divided by the plane ax plus by plus cz plus d is equal to 0, then in that case m upon n will be minus times ax1 plus by1 plus cz1 plus d on ax2 plus by2 plus cz2 plus d, right? Suppose this segment is AB, and in plane ratio is m is to n, and case will be this, right? Okay. Okay, now let's come to next heading, which is direction angle and direction cosines. Now again let us draw a figure having a parallelepiped having one vertex at origin, and this is point, say ABC, and this vector OP is say R vector, and this P having foot of perpendicular on x-axis at M, right? Having coordinates A 0 0. Also projection of OP on x-axis is OM, right? Now if this OP is having angle alpha with x-axis, angle beta with y-axis, and angle gamma with z-axis, then these angles are called direction angles, and this becomes mod r cos alpha, right? Which is projection. Okay, so I will write in this here, alpha, beta, gamma are called direction angles, and cos alpha, cos beta, and cos gamma are called direction cosines. Okay, and also we have defined projection along x-axis. Projection along x-axis is nothing but mod r cos alpha. Say it is r1. Okay, projection of along y-axis will become obviously mod r cos beta. Say it is r2, and the projection along z-axis is mod r cos gamma. Say r3, and also r vector is nothing but r1 I cap, right? R1 is nothing but the component of r vector along x-axis, which is obviously mod r cos alpha. Okay, so in compact form I can write mod r is, r vector is equal to r1 I cap plus r2 j cap plus r3 k cap, which is obviously mod r cos alpha I cap plus mod r cos beta j cap plus mod r cos gamma k cap, right? I can take mod r as common, so inside this will be cos alpha I cap plus cos beta j cap plus cos gamma k cap, right? So mod r vector upon mod r is cos alpha I cap plus cos beta j cap plus cos gamma k cap. So this cos alpha, cos beta, cos gamma are bulky, so I can write, or we may also define these as L, M and N. So this r vector upon mod r is nothing but unit vector r cap, and which is L I cap plus M j cap plus N k cap, right? Or if I take modulus, then it will be L square plus M square plus N square is equal to 1, right? So L, M, N are called direction cosines, okay? Or cos square alpha plus cos square beta plus cos square gamma is equal to 1, right? From this I can also write this thing in sine, in terms of sine, which is sine square alpha plus sine square beta plus sine square gamma is equal to 2. Also this can be written as like this: cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to -1, right? Because cos 2 alpha is nothing but 1 minus cos 2 alpha is nothing but 2 cos square alpha minus 1, or 1 minus 2 sin square alpha. From there I can write this -1. Okay, let us take a question. Question is, find direction cosines of r vector is equal to 2 I cap minus 3 j cap plus 5 k cap. Okay, so I know 2 is r1, minus 3 is r2, 5 is r3, or you can say this 2 is projection of r vector along x-axis. Okay, so I have to find the direction cosines, means mod r cos alpha I need to find. So I know mod r vector upon mod r is nothing but Li cap plus Mg cap plus Nk cap. So here mod r is nothing but root over 2 square plus minus 3 square plus 5 square, which is root over 38. So therefore r vector on root over 38 is equal to 2 upon root over 38 I cap minus 3 upon root over 38 j cap plus 5 upon root over 38 k cap, right? So this is r cap is upon root over 38 I cap minus 3 upon root over 38 j cap plus 5 upon root over 38 k cap, right? So L, which is cos alpha 2 upon root 38, M is minus 3 upon root 38, and N is 5 upon root over 38. right? So these are the direction cosines. Okay. So students, for this class we are done. Let's meet in next class. Till then, bye bye and take care.